everyone. In this video, we are going to present our integrated design project, the plant monitoring system. First, I would like to introduce our group members starting from me, Alan Chang, Nurul Fatiha, Roland Soh, and Xavier. I would like to start the introduction with the problem segment. As industrial scale farming requires huge manpower management and maintenance costs, it is safe to say that agriculture has large impact on economy. The environmental impact of traditional farming like climate change, pollution, and waste is also a major concern. Human population is increasing each year. Agriculture production need to keep up to meet the demands of consumers. By growing your own vegetables, fruits, etc., you do not have to rely on commercial agriculture to meet your demands. IoT, Internet of Things, has become one of the major trends in technology and business in recent years. IoT also being used in many fields like smart homes and smartwatches. With the involvement of IoT, smaller businesses and hobbies can grow their own agricultural products cheaper and environmentally friendly on a large scale. By involving automation in this project, precision farming and efficiency can be increased and achieved. Side effects like pollution created from fertilizers, pesticides into earth grounds can be reduced. Management can be done remotely and does not require constant interference like checking if the plants have been watered and the fertilizer. A combination process of fertilization and irrigation is called fertigation. A machine that does this is sold at a high price and is not easy to operate. Our project's aim is to make it more accessible to amateurs and beginners by simplifying the process. I would like to pass the presentation to my groupmates. Fatiha.
Methodology. Before I go through how the system works, I will list down the IoT features that are implemented in this product. There are 3 of them. One is water level monitoring, second is fertilizer level monitoring, and the third one is pH level monitoring. All 3 of these features will be available on a web page where the users can check on any of their device, either from a desktop, from a phone browser, or from a laptop. Now, for the monitoring system, first we will look at the water level sensor. For both fertilizer and water level sensor, both of them will be using the same concept. Over here, there's 2 tanks. One is filled with water and one is for fertilizer. Both of the tanks each have a water level sensor. And there are 3 level of depths for simplicity. One is high, medium, and low. And when the sensor detects the water level or the fertilizer level in each tank is low, the users will be notified so that the users can refill the water or fertilizer. For the pH sensor, there will be one sensor in the first layer of the pipe, and let's say there's too much fertilizer released into the pipe, the pH sensor will be able to detect if the reading is high. So when the value is high, it will let the water from the water tank to flow more into the planter automatically. And when the pH is low, it will let the fertilizer from the fertilizer tank to add more to the pipe. And all this is achieved by using a actuator where the actuator would actually block off the flow of the water and the fertilizer. And this is the sample from the web page where it shows the pH level and the water level. For the water level, this assumes that 2.5 is the median value of the water level. So anything above it means that the level of water inside each tank is high. But if it goes lower than that, it means the water is being used, and the flat graph shows that there is no more water inside the tank. And the pH level takes the neutral pH value, which is 7, and when it goes on 7.2.4, it means the pH level is too low, and if it goes beyond 7.26, it means the pH level will be too high. Moving on to the cost breakdown, the maximum amount of budget allocated is 150 ringgit. For prototyping, we're using 3 of these items: the ESP32 Wi-Fi module, PH4502C sensor, and the water level sensor. We use only one of each, and the total cost brings down to 120 ringgit and 74 cents.
This is the IoT system we built, and this is the prototype to implement the system. This is the water level sensor, and this one is the pH value sensor. We start the program, and the data will appear in few seconds. This is the web server that we built for this system. Okay. The system will notify the user when the water tank is empty. So now we disconnect this. So this is the alert.
Hi, greetings. My name is Xavier. I'm from Group G, and we'll talk about the limitations on our project. As you all know, the MCO has been ongoing because of the COVID, and we would like to explain on the limitations that has impacted, how it has impacted us in this project. One of the main reasons is we have no flexibility in to have meetings. So how we overcome this is we have online, I would say WhatsApp calls, video calls, or we use Zoom. previously. So we have always communicated through WhatsApp, and through this we were able to we're just able to delegate tasks, and hopefully I would consider this a success because with the time in our hands we were able to understand and we're able to comprehend how we can proceed with the project, and I think that is one of the good sides of having the MCO. But another big limitation with the project would be arrival of items. Like we have ordered sensors, and we have also ordered a few things to make a prototype, but because of it we were unsure of the size of the prototype at the time being. So in the beginning stages we were planning the original product on how big it was, so we knew that we had to downsize in order to use whatever we have in our homes. And we were not able to start on the project early, especially in the automation and coding part. As you can see here, the sensors was one of the main features. This is a pH sensor where it detects the pH value of the water of the project, and this is one of the main things in automation that was important. And one of my groupmates were not able to start the coding for this part, other than simple and basic coding. And the other reason for the MCO is because we're unable to purchase items for a prototype, and I feel that earlier on in MCO, although we did have a chance, but we did not expect the MCO to happen, so we did not prepare earlier and get the prototype. But through this we were able to gather resources by asking who has certain items, like the project uses bottles and it uses PVC pipes, and I found that this was lying around, and we decided that who had the most resources, and that person will be delegated to create a prototype. And through that we were able to complete the prototype in time, and this is how we did it, by just delegating tasks and checking who had or which items who had more resources to build a prototype. One of the main limitations that we were not able to solve is to produce sufficient quality in the prototype. It's because we were using materials that are available, like the bottles and the PVC pipes, and I understand that these bottles can degrade over time, so that's why it's just a prototype, and we weren't able to work on the real product to begin with. So the next one is limited resources, meaning we're not able to find or look for advisors or lecturers for help. In this time it was only email basis, and there's only so much you can ask through email. But we decided to resort to YouTube or resort to these other similar projects, and that gave us more information on agriculture. They gave us more information on how to build the prototype efficiently, and it still functions the same way as it would of the complete project. And one other limited resources is that we were not able to search for more items. Like I said, we have no flexibility on going out to buy items. We are only left with online e-stores, and which will also take time to arrive, and that's why we did not resort to do that. And because of this, we were not able to get certain items like other sensors for temperature, and other sensors for timing, or and I believe these sensors could be beneficial, but we decided to focus on the pH value, and that's why we were only able to get the pH value sensor. And last but not least, the prototype does not have automation, and this is one of the limitations that we have for this prototype. I hope that this is clear, and I thank you for watching.